Okay, so yeah, I want to share with you here the iCollege from the old one. If I can't share it, then I will share. Can you see it? Everybody can see the video?
Yes.
Hello?
Yes.
Yeah, we can see it.
Can you hear?
Yes, we can hear you. Oh, we can't hear the video though.
Oh, really?
No, we can't hear the video. We hear you, but not the video.
Well, me. So I'll try to. Yeah, that's always the problem with the. I'll stop sharing it, see if I can. If it's not, I will upload it today after the lab. But anyway, I will share something else. We'll share the actual uh, the uh, the actual. So let me take this one out. This is the actual lab report template, correct? So if you look at this, I want from you to, because we are not doing the actual lab, um, so everything is recorded, everything is, I hope it's recorded, everything. So we will have the lab here. This is the data here. I wanted to copy all of it here, and it goes all the way down. 2 parts. That's the first part here of the experiment. Then I will go and explain the experiment itself. But that's what I need from you to copy this, correct? And the second part is here. This is the second part. This is the second part. And your introduction, that's in iCollege posted already. Your introduction, procedure, and discussion and conclusion will come using, you have to write your own, rephrase whatever in this template here. I put this template for you, and I put the lab report as well. How does it look like? But this is just a template here. Let me take this one here out. So as I said, if you look, this is starting with the introduction, write it your own, state. See, that's a template. Procedure is state your own procedure. Introduction your own from the lab report, the lab procedure. I'll show you here. This is the data. That's what you have to copy it as is, because we are not doing actual experiment. And this is another table you need with the metal, with the elements. It can be metal, metalloid, or non-metal. And number of electrons, number of protons, number of neutrons. How does it look like, this element? And here, how much the percentage covered discussion, that's using your own word, and the conclusion, your own word, and you copy the post-lab questions. You just copy. This is Microsoft Word. You can copy and paste, easy. That's in iCollege. Now, this is the template on how to write the lab report. We need copy the 2 tables here. The data and the introduction, procedure, discussion, and conclusion. It has to be in your own words. And what's happened is, after the conclusion, you copy and paste the post-lab questions. Now, the post-lab questions is part of the whole thing, but you are responsible for them. They are now open book for you, but you are responsible for them when it comes to the quiz or midterm, because some of those questions will appear in the quizzes and the midterm exam. So let's go and look at the actual. Let me stop sharing. I want to share something else. Here it is. This is the experiment which would like to share here with you. This is the experiment here, which we have a mixture, heterogeneous mixture, made of, let me write it here. This mixture made of 3 components, heterogeneous mixture, not homogeneous, heterogeneous. So this, again, is, I'm writing with this mouse. It's not really get that good. I'm using the laptop of the university. Therefore, it's not touch screen, so it's not allowing me to use my stylus pen. But heterogeneous mixture made of, this mixture is made of 3 components. First component is sand. Second component is salt, kitchen salt. And the third component is fertilizer, it's ammonium chloride. Let me just ammonium. I apologize, the mouse is not really a good way to write. Oh, my stylus is not working. My stylus pen cannot work because you have to have an iPad or touch screen laptop, which is the university is not providing us with this. But anyway, so we have 3 components and we have those heterogeneous mixture because you can see it in the real life. Those are heterogeneous mixtures. So out of this heterogeneous mixture, what you will do here, we have today our goal to separate each component of this heterogeneous mixture by itself and determine the percentage contribution of each component to the whole mixture. Okay, so we have to separate sand by itself, salt by itself, ammonium chloride by itself, and determine what the percentage of each of those elements present. And I show you, I give you, because you are not doing the actual experiment, you can use the data I gave you. That's how to separate the whole thing. I'll explain how to separate those. We will be using the physical properties of each component to separate it from the rest of the mixture. So for those 2 here, first for this one here, ammonium chloride, it can sublimes at mild temperature. So we'll take this advantage of the sublimation temperature. I can't write this, is not writing very much. Sublimation. Sublimation point or temperature. So the salt's not sublimes and the sand is not subliming. So what will happen is if we heat this one here with the mild temperature, all the ammonium chloride is gone. Correct? Then we can go and reweigh the whole mixture without ammonium chloride. Do we know how much we have started with? We can determine what ammonium chloride lost, correct? With these 2 ones here, we take advantage on the solubility in H2O. And solubility always is connected to it is H2O soluble or not. So take advantage to know which one. So it looks like Sand is not soluble or insoluble. Sand is insoluble. And the kitchen salt is soluble. So now one more thing here to know, the formula of each of those. So here it is. Let me take one out and come up and then say, I'm clearing this. Well, it turns out to be sand, SiO2. Sand, SiO2. That's sand. And the formula for ammonium chloride in this heterogeneous mixture, ammonium chloride is NH4Cl. And this is called here ammonium chloride. And then this is the second one, second component. First one here. And the last one maybe here, kitchen salt, sodium chloride. That's our kitchen salt or salts. So those are the three components are contributing to a heterogeneous mixture. And they are in a mixture. We don't know how many percentage each component contribution to the overall percentage of the whole mixture. So we'll take advantage of the fact that physical properties are different. Sand and salt are different in solubility in H2O, while sand is insoluble, not polar, so it will not interact with H2O. Sodium chloride is polar ionic compound, and it will be soluble. It will be what? It will be soluble in H2O, so we can separate them. The ammonium chloride is sublimes at mild temperature. We take advantage of this fact, so we can get rid of it at the beginning of the mixture and then calculate back how much left of the mixture after weighing, and then the difference in weighing will give us what? Will give us the amount of ammonium chloride. The amount of ammonium chloride then be divided by the total mass. So you will take at the beginning, I'll explain the experiment. You will take 3 grams of the sample, and then from there you can determine the whole mass amount. And then if you know the whole mass amount, then you divide the amount of ammonium chloride divided by the total mass of the mixture, multiply by 100, give you the amount of the percentage of ammonium chloride. So let me go and explain first the experiment, and then we'll come and look at the calculations and everything. It's not really difficult. It's a nice experiment. So here it is. So go out here. Here's the procedure here. You will have two crucibles. First crucible is assigned the number 1, and the second one assigned the number 2, and accompanied with watch glass. So you need to weigh. How many we say? 2 watch glass. 2 dishes or evaporating dish, or crucibles. Two evaporating dish. One and labeled 1, and the second one labeled 2. But you need the watch glass for 2. So number 2, you need the watch glass. Here it is. This is number 2, it has a watch glass, because that will be using it for sodium chloride which is start popping. We put the watch glass on the top of it to prevent it from prevent sodium chloride crystals to get out because of the heat of the drying. Correct. So therefore, you have to weigh both watch glass and the evaporating dish number 2. Okay, and you weigh evaporating dish number 1, empty, nothing inside. Correct, guys? Then you will weigh about 3 grams inside this what? Inside this crucible. So weigh first those you have to weigh those evaporating dishes 1 and 2, and the 2 with the watch glass, empty, nothing inside them, empty. We have to know their masses, empty. Evaporating dish number 1, evaporating dish number 2 plus watch glass, that will give you the mass of each evaporating dish 1 and 2, empty, nothing inside them. In the number 1, evaporating dish number 1, you will weigh inside it the mixture, hydrogen mixture, about 3 grams, but you have to record exactly how many grams you have. Everybody's following? Everybody's following? Okay,
Yes.
good. Okay, so
Yes.
good. Yeah. So now we know inside this evaporating dish, we weigh 3 grams, correct? We go and turn on our Bunsen burner and heat. When we heat, the ammonium chloride starts smoking. We'll wait until the whole smoke is out. Take evaporating dish number 1 down to cool down and go and reweigh it. Correct? Everybody's following? Now, what's inside the mixture now? Inside the mixture, we have silicon dioxide and sodium chloride because the ammonium chloride had already gone with the smoke. Sublime, it did sublime through the heating process. Correct? Let me now stop sharing and go back to this template here again. Let me share the other one. Just to show you here, guys. I will be back and forth between this template here and the procedure. That's where I can explain the numbers there. So here, guys, and I hope it's recording. I think it's recording now. So here it is, guys. And if you look, this is mass of evaporating dish number 1, empty. Correct? And we have here mass of evaporating dish plus glass, empty. So that's the beginning you will do. You will add 3 grams of dish number 1. So then the mass of dish number 1 with the amount inside of the heterogeneous mixture, you have the sand, correct? And sodium chloride and ammonium chloride. So that's the whole sample of the whole heterogeneous mixture. The whole sample of the whole heterogeneous mixture. Okay, so now we have inside the sample till here, we have 3 components: sand, silicon dioxide, we have sodium chloride, kitchen salt. Oops, what did I do here? It has sand, it has kitchen salt. That's N, by the way, guys. Na. Yeah, I apologize. I can't use the stylus. It's not a touch screen. So, and then the third one is ammonium chloride. Correct? So, any question about the step 1? Empty, correct? Added the mass 3 gram. The sum will be both, correct? When you add 3 gram, you reweigh, and the mass of the crucible empty plus the 3 gram will come up to this value, correct? After heating here, this is the what's inside, those 3. This one here comes in, this one here. We are answering this. What's inside? Well, you have those 3 ones are inside, okay? So, and that will answer. Those are the 3 components, correct? Now, we start heating, correct? After heating, the question is what we will have. We'll have, after heating, we'll have only 2 left. The ammonium chloride are blanked out. Did you select? Could you talk the question, because I can't. Somebody has a question here. Could you unmute yourself and then ask the question, please? I can't go to the chatting and come back. It will be just too much of work to chat and then go back to the sharing. If you have any question, unmute yourself and talk to me, please.
Is the procedure PDF in iCollege? I wasn't able to find it.
Oh, the PDF, I will post it. I will post it. That's in the, you will find it. You will find it inside the, yeah, I'll post it. That will be in there. I'll post it. Yeah.
Okay, thank you.
I'll post it, yeah. It should be there. I don't know why it's not there, but it should be there. I'll post it. No, don't worry. Okay, guys. So now if you look at this, this is, you can find it as in iCollege. You know where? That's underneath the, if you click on the link, if you click on the link, experiment number 4, click on the link, you will get 2 formats, one PDF and one Word. Did you see it?
I see the template and a filled out report, but I don't see the
No,
procedure.
Not the
PDF.
template. The template, you see it obvious, but if you click on the link of the experiment, go up a little bit, the link, it said experiment 4. Click on the link over there. You will see those will appear there with some video tubes, video tube there. Can you see it?
I found it. Thank you.
Okay, it's there. Just yeah. Okay, so now after heating, you will have got rid of sodium of ammonium chloride. You'll have only 2 components here, correct? After the smoke is gone, everything is cooled down. You go and weigh dish number 1, which is now filled only with those 2. Filled with those 2. Nothing inside them. Okay, guys. Now you will take dish number after cooling, dish number 1 without ammonium chloride, correct? And you will go all the way and go from the sample you started with. The sample started with minus now what you have here, correct? Will give you amount of what? Amount of ammonium chloride. Everything's following? Yes, no?
Yes.
We have a mixture made of 3. We weigh this mixture, we know the mass of it exact, correct? So exact, I mean, it's here, this value here. With the crucible, with the, evaporating dish number 1 or crucible number 1. With the evaporating dish number 1 with the sample 3 gram, that's we know. But after heating, the sample had lost one of its component, which is the ammonium chloride. We go and cool this sample after heating, and then weigh it. We find this is the amount. The rest of it means the difference between those weighing 46 point something and 45 point something. That will give us the amount of what? Ammonium chloride, which already sublimed. Okay, guys? So now, if I take this amount here, let me switch another color. If I take this amount here, guys, and then divide this amount here, correct, by the sample amount and multiply by 100, I get what? I get the percentage of ammonium chloride inside my sample, correct? Everybody's following? So, and that's what I have here. Look, that's my sample, a percentage of ammonium chloride. After cooling, I got what? I get a mass. I subtract this mass from the whole mass with the crucible I started with, which is this number here. Again, circle it again, this number here. That gave me this amount here. This is amount of ammonium chloride divided by original mass amount, which is here, multiply by 100, give me this value here. That's ammonium chloride is done now. Ammonium chloride is what is done. Now we have to go, correct? We know that the mass of the watch glass, second one, evaluated the second one with number 2 with the watch glass. We know the mass of it, correct? So we'll go back and look. I'll stop sharing here. And I want to share the PDF again. So I'm going to share the PDF again and said, okay. So now we are dealing with, maybe it will write me right here. No. Yeah, that's too big. This is dish number number 2, sorry, correct? Empty with the watch glass, correct? So what I will do here, I will add just bear with me a little bit. I will add, remember this is dish number 1, correct? I will add to this dish here, after I have gotten rid of the smoke, ammonium chloride, cool down, weigh, and then get the amount of, determine the amount of ammonium chloride. Now I can separate in this here step. I have both. I have silicon dioxide, the sand, plus the sodium chloride. I have to add cover H2O to take advantage of the fact that sodium chloride is polar and soluble in H2O. Sand is not polar, it's not soluble in H2O. So I'll add here, it says 10 mils. 10 mils I think is too much, but I told the student to take 5 mils first. And then I'll add here inside this 5 mils of tabor, and then we'll stir the solution here just to make sure it's sodium chloride is soluble. Then we decant the liquid here, keeping the sand solid at the bottom of dish number 1. So dish number 1 will have what? Will have sand. Dish number 2 will have salt, kitchen salt, in a liquid status, in the liquid phase. Okay, so I'll have another 2 to make sure that I'm really covered and I'm really moving all the sodium chloride into the solution in the dish number 2. Add additional H2O, but first we added 5 and decant. Now we can add more 2 mils and stir very well, and then move to this dish number 2. Okay, guys? Now we have, let's look here. We have two dishes. This dish here has sodium chloride solution, colorless solution, colorless. And dish number two here. This one here. Dish number two here has sand. And it's wet sand. It's wet. Okay, guys. Now I separated the sodium chloride from the sand by adding H2O twice. First time 5 mils, the second time 2 mils. Decant the whole liquid in the other side. Now I'm ready to heat dish number one by itself to dry what? To dry. So I'll go heat and dry. This is dish number one. Dish one. Okay, heat, and then I will get dry, silicon dioxide, sand. Here I have a liquid solution. I have to watch. It's a solution, sodium chloride solution. It will start, crystals, white crystals of sodium chloride will start forming and will start popping because of the pressure, vapor pressure of the boiling H2O will take those crystals up. So what you will do, you put the watch glass on the top, correct? And you keep heating until everything is really evaporated in the evaporating dish number two. So now we have here dry sodium chloride. From liquid sodium chloride solution to a dry sodium chloride crystals. So cool down and reweigh. So cool and weigh. I can't write it away. And here, dry sand, I have to go and wait. Okay, guys? So I have the weight of the dry sand in dish number one. I have the weight of the dried sodium chloride white crystals in dish number two with the watch glass. Remember, watch glass will have traces of this white crystal, but we weighed both of them at the same time. I mean, separately, but we have to know the weight of the watch glass with dish number two by themselves and the watch glass number two inside the sand. So any question, I'll go back to the Microsoft Word to show you the calculation here. Okay. Stop sharing. Share. Okay, so now we have here we have mass of evaporating dish glass, correct? We did that before. Now, after drying the solution, dish number two, white glass and salt, we got the salt, the white crystals, correct? Everyone's following? This minus this number here will give me what? The mass of what? The mass of the salt, correct? The mass of the salt. So that has to give me the mass of the salt. So mass of evaporating dish and the watch glass is 172.48, correct? That's empty. Now filled with the salt is this one here. So the difference between filled minus empty will give us this amount. Correct, guys? Any question, guys? Correct? So then I know the mass of this salt. I have to do it the same way we did. So let me clear the so now I have here, guys, the mass of the salt here is here, divided by the mass. The 3.0 is the mass of the whole mixture. And the 0.7 salt here, remember? This is the salt we got. And that's what then divided by the whole, this number here, divided by the whole number, 3 grams, multiply by 100, give us the amount there of the sodium chloride percentage. Now, left for us the sand, correct? We evaporate the sand in dish number 1, and we heat it to dry it and cool it and dry it, and we got mass of the sand. That mass of the sand, dry sand in the evaporating dish, correct? But we know what's the mass of the sand. What is this value? Somebody will tell me. Somebody will talk to me. Unmute yourself and tell me what is this value here. So now this is the sand with the dish number, evaporating dish number 1 mass. But when we dry the sand, we have to subtract what is this number here? What is this number? We have to subtract this, the filled dish. This number here, you can see, minus the evaporating dish number 1 mass empty from all the way step number 1. This is dish number 1 mass empty, nothing inside it. So you get 1.4 what? Gram sand.
Yeah.
You come here, take the sand here, 1.4, divided by the total, you get 46.7%. Now we want to see the recovery from the whole thing. So we add all the gram, we add the 0.7, this is the salt here, this is the sand, this is the sand, sorry, and this is ammonium chloride. You add all those grams, which are given here, this gram here, and the salt is ammonium chloride is here, correct? And this 1.4 is the sand. So 0.78 is the ammonium chloride, and the ammonium salt is, the salt is 0.7 here. You add them up, divide them by 3%, you get total recovery 97%, 97.7, so it's now about 98%. This is excellent recovery. It's excellent recovery. Correct? Excellent recovery. And this is the ratio between about 25 to 25 to 47, something like this, or 46%. So, any question about the data here? Any question? Any question? Any question? So now this is part 1. This is what? Part 1. We did part 1. Any question about part 1 of the experiment, please? Any question? Everybody's following me? Everybody's following? Yes, no?
Yes. Yes, yes, yes.
Yes.
Okay, good. Good. Now part two. Part two, you get vials. About number of the vials are here. You get this vial number 1. This is 2. This is 3, 4, 5, 6. They look like, some of them, they look like really hospital blood vials when they take your blood for testing in the lab. So it's the same vials, but they put those elements inside those vials. So they put about, you have 6 vials, 6 elements, and they write the name of that element so you are not confused which is which. So give you aluminum, carbon, iron, magnesium, and silicon, and sulfur. So you have to look at the periodic table. You have to have periodic table handy. Determine the symbol of it in periodic table. Determine their appearance inside that vial. Correct. Carbon is charcoal, looks very dark black. Iron is black. Aluminum is gray, shiny gray. Correct. Magnesium is shiny gray. Silicon is a little bit dull gray, so it's grayish type of element. And then sulfur is very, very bright yellow, very bright yellow crystals. Correct. All those are solids. All those are solids. Now, the question is, that's the appearance. The symbol from let me see here. This is the symbols here from periodic table. And this is, we explain the whole appearance. Now, we are interested in, and that's what the whole idea is. We are interested in this, really, mostly here on this. You have to look up in the periodic table. Each element, we need 2 information: atomic mass, atomic number, mass number, and atomic number and mass number. So when you know this one is atomic number here, and atomic number, and this is mass number by then. So if you subtract this atomic mass from this, you get number of what? Of neutrons. Atomic mass minus atomic number will give you the neutron number. Everybody's following? Now, the atomic number is number of what? Electrons and equal number of protons, because it's not charged, correct? So it will be, for example, let's pick up on carbon. Carbon atomic number is 6. Atomic mass is 12. Correct? So the subtraction of this will leave me with number of proton is 6. 12 minus 6, 6. So neutron. How about the number of electron protons? Well, atomic number equal number of the protons equal number of electrons. 6, 6, 6. So it remains 6 here, 6 here, and this is 6 here. No change. Now ask yourself, what type? If it's metal, non-metal, or metalloid? Well, carbon is non-metal. And as you can see, aluminum is metal here, carbon is non-metal, iron is a metal, magnesium is a metal, silicon is non-metal, or silicon is the only one metalloid, and the sulfur is non-metal. Silicon is metalloid. Silicon is what? Metalloid, which can act as a metal or act as non-metal depending on what the condition it is in. Correct? So that's the second part of the lab. So your task is to copy. Let me clear this. use the data here. It's like you are pretending you did the lab. This is part 2, correct? From the lab. You pretend that you did the lab, correct? We did not. Actually, if we are today in the lab, we have done this. So this is the second lab with heating and all, subnetting those mixture to its component and calculate each percentage. So I'll stop here. I'll recall if you have any question. Any question?
So in pretending that we did the lab, are we going to use that data that you have provided?
Correct. And the lab report,
Thank
then the
you.
procedure and the introduction, use your own because there is a lab here. Let me stop sharing here. Go back and share. Yeah,
Understand that. Thank you.
yeah, that's this one here is already this I mean this file PDF or Microsoft Word as a matter of fact. So this is given to you in the iCollege. So just look, rephrase your the whole thing. And I think I have in iCollege an example of this. I do have, I think. Let me stop sharing. But this is the introduction from the goals of the experiment, not the procedure, but there all the way at the beginning of the lab. Objective, that's your goals here. You can express it in your own words. But let me not rush to this. Let me go and share. I hope iCollege, I have an iCollege. I'm not sure. Share. Does it show this one here? What can you see now?
The video.
We see the video, but we can't hear it still. Probably YouTube isn't letting the audio play.
Will this be
No,
posted?
I hear it. From my part, I hear it. I think it has to do with my own.
You have to share with sound. If you don't share with sound, we can't hear it.
Share computer audio. Let's see.
Right.
Can you see it? Can you hear it? And
Yeah, we hear it now.
okay. Well, if I make it darker on the screen and here, darker here, there will be then the recording will be. Yeah, just I'll put all the examples here. You can see it. So I'll take the pen here. So today we'll have a mixture. This mixture is made of 3 things here. I hope it will write. Yeah, ammonium chloride, and then we have well, you want me to continue on this or just stop sharing? Because you can, this about 30 minutes. Let me just close it here. Let me stop sharing, correct. Guys, you want me to share this video because it's inside iCollege. I'll put it inside iCollege, but it's already inside iCollege. It's about 30 minutes. You want to watch it? Guys, hello?
Yeah, you can go ahead and
Sure.
play it.
Watch it?
Yeah.
30 minutes.
Yes.
Okay, here it is. Sharing. So this is a mixture of three. Okay, so let me just change the pen here. This one here called ammonium chloride. This one's called sand. This one here is sodium chloride. Sodium. So this mixture is mixed together, and then we will try to separate all those components of this mixture by themselves and determine the percentage recovery. Okay, we have to determine what the percentage recovery. So mixture of three. This is by far is, as you can see, is not a homogeneous mixture, it's a heterogeneous mixture. Just for the fact, if you look at it and I'll open it for you here so you can see it in the, you can see here, you have brownish, grayish brown color here. And if you look at this, so this mixture here made of three, the ammonium chloride is white crystals, just to let you know, all those are solids. This is a white solid. This is white solid. White solid. And this is dark gray solid as well. All those are solid mixed together in a specific percentage, and we want to separate them. So we'll be using their physical properties. What the physical properties are? The physical properties are as follows here. Ammonium chloride has a sublimation feature that's both the other ones, sand, silicon dioxide, and sodium chloride, kitchen salt, they don't have. So this one will be used its sublimation feature, sublimation. So sublimation physical property, okay? Sublimation of physical property. The sand, then we separate this one by itself first, out. Then we'll come to the sand here, plus sodium chloride. Now we'll look at their solubility, their polarity. This is non-polar, okay? And this is polar. So we are using the other feature of the both of the two solids here, sodium chloride and silicon dioxide. Silicon dioxide is called sand, and sodium chloride is a kitchen salt, correct? So we'll add to them a polar solvent. So we'll add to them polar solvent, H2O. So then we'll see that sodium chloride soluble in H2O. This one is not soluble. So that's a good way to look into the whole thing. So we can separate the first one by sublimation, by heating. It sublimes at temperature maybe 300 degrees or something, 340 degrees. And then the solubility, then we'll add cooling everything, add the H2O to this solid. Sodium chloride will dissolve with the solution. Sand will remain as is. Then we separate both of those solution, sodium chloride, aqueous solution, and sodium sand is wet a little bit. So we will heat to dryness to evaporate all leftover H2O inside those two crystal solids. We'll have then sand by itself and sodium chloride by itself. Go and make some weighing and calculation, and then we can see the recovery of the three components. That's the whole idea of separation of this solid mixture made of ammonium chloride, made of sand, made of silicon dioxide, made of kitchen salt, which is sodium chloride. So that's the first part. I'll come back to the first part, but before the first part, we go to the second part. We can start whenever there is heating in between, we can do the second part. The part here, as you can see, I distributed among yourself guys a periodic table, correct? And this periodic table, you will go and look at the material. Let me just get this one out. We'll come and look at the material here as, let me share still. So you'll come here, the second part. If you look at the second part, you look at the element here. All those are given to you in the back. Like I have sulfur here, correct? What's the atomic symbol of sulfur? What's the atomic of sulfur? You can come in the periodic table. Using the periodic tables, you look where sulfur is at, and then you write what its symbol. What's the symbol of it? For example. So for example, I would say, okay, let me just do here. This I will do for you sulfur, and then you can do the rest. Okay. So sulfur is S. Okay. Appearance is bright yellow solid. Correct. That is yellow. Yellow solid. Just write it here. Let me just take everything here. So let me write it here. So this one here is S. This one here, appearance is yellow. Yellow solid. Okay. Atomic number, what's the atomic number of sulfur? Where is it? Look at atomic, where is it? It's here. Group number 16 or group number 6A. 6A, if you look at this, 6A or 16 underneath oxygen, and the atomic number of sulfur, as you can see, how much is it? 16. So I'll write 16 here. 16. Atomic mass, how much is it? Okay, yeah, it has a fractional because of the atomic weight, average atomic weight, because due to the isotope presence in nature. So we're not, in order to get the exact number of protons and electrons and neutrons, we have to round up this fractional atomic mass appeared in the periodic table into whole number, because protons, neutrons, and electrons, those are the smallest units within the atom. And the atom is the smallest unit of any element found in nature. So or produced in the lab. So you will see here the atomic mass or mass number, that's called mass number, is what? Rounded to whole number will be what here? 32. So number of the protons, it looks like is number of the protons, number of electrons will be the atomic number is atomic number 16. So number of the protons will be how much here? 16. Number of electrons how much? 16. Well, You add to this, I will make this one here. You'll add to this one here number of neutrons, because that's missing here. Every time I teach this lab, I said we have to add another column here called number of neutrons. And so this is protons are B plus, electrons are E negative, and neutrons N zero. Right? So how much is the here? That will be here. How much is it? It turns about to 32 atomic mass minus the number of the protons, because atomic mass is mass of the number of the protons plus number of neutrons. Electrons are so tiny, they are not part of atomic mass consideration. So 32 minus 16 will be what? 16. So you write here 16. So when you write this data in your lab report, I will give you tonight, I will add another column. Guys, I will add another column. That's a neutron. So 16. Now I have to look into the periodic table again. Is sulfur is a metal, non-metal, or metalloid? What it says there? The periodic table here I'm showing. Is it a metal, non-metal, or metalloid? It is non-metal. So here it is. Sulfur is non-metal. Perfect. So you do the rest of the whole thing in the lab. You come, and the appearance is, as I said, you look at the whole thing here. The appearance is yellow solid. Okay, yellow solid, and then you take the rest of all this one here. This one here, aluminum shots. So aluminum have the appearance of them. You go to periodic table, get the idea of the atomic symbol, and then atomic number of protons, atomic mass, number of the electrons, number of neutrons. Correct? And then you determine whether it is metalloid or non-metal or metal. Which one of those you can tell me is a metalloid? Because we know the metal, non-metal. So you have a stairs there. You look at this, there is a stair you're starting to move, and it goes, stairs goes like this all the way down the stairs here. You have seven elements are metalloids. Which one of those here you have in your exercise, bar 2, is a metalloid? Which one? Aluminum? No. Come on, guys. Look at the periodic table and tell me. Silicon, correct? Si. Periodic table does not show, but it does really showing you that's the boron, silicon, and then it goes arsenic. It goes like the silicon, germanium, arsenic, and then kilo and astatine. So it's those are, I can show you if you want to here. Maybe let me go here just, and then I will say I want to see. Let me take this here and just bear with me a little bit. I'll just show you the metalloids. Let me show you where the metalloids are here. Let me share the Here they are. Hold on. Let me stop sharing and then switch to the share this. I'm sharing now for you the periodic table here. Your periodic table does not show the metalloids. So those are type of light orange color. Start with boron. Can you see the stairs? Then let me maybe come at that with color that's very familiar. So then I will say this is boron here, guys. Silicon, then germanium, arsenic, antimony, antilor, and astantine. Those how many you have? 2, 4, 2, 4, 6, 7. I circled them. See here? I circled those. Those are metalloid. And silicon, silicon is one of this. Silicon is one. They call them the stairs. The stairs element is recognized as stair element. They really come as a stair. So this like stairs. 7 metalloids is well known inside periodic table. Okay, the difference between metalloids can act as either or depending on condition. They can act as a metals or they can act as metals. This is the first part. Okay, let's go for the first part again, which is separation of this mixture. So what we have to do here, I'm not telling you all the procedure, not all details, but at least you will have in your hood setup is the setup will be looking the setup will be looking like this here. So first of all, you will have two you will have maybe I have to go and stop sharing because it does not stop sharing. And then I will share again the Microsoft Word. Okay, so now it should come. So here it is. You will have two. That's dish number 1. Dish 1. And then you have to have dish 2. And with its watch glass. So you will weigh each one separately here, empty. You will weigh first what? You will weigh each one empty. Empty. And this is combined weight. Okay, guys? So this is first what you have to do. First, you weigh 2. This is the picture here. Let me show you here. This is the picture of the evaporating dish. Those are the dishes here, evaporating dish. They look like this. Take the one that has depth inside, so you can add, because we will add some tap water into them. So therefore, don't take the flat one, but take one like this. So this one and dish 2, the same thing, and plus a watch glass from your drawer. Correct, guys? So you have 2 of those empty. Now, when you are done with this, then what you will do here, you will go and to the sample here. I have shown you the sample here. So the sample is mixture of both 3 components here. And don't see the number of it, but you might see if they have numbers of them, you have to record the number of this mixture. This one does not have a number. And if it does not have a number, don't worry about its number. So this mixture has ammonium chloride, sodium chloride, and sand, silicon dioxide. So 3. So what you will do here, you will weigh out of this 3 grams. So you know dish one, in dish one, you will weigh what? Your mixture, 3 grams. So the first thing here, you will weigh 3 grams. You will weigh 3.00 grams of your mixture, in dish number one. Of course, you know what's the dish one. You have to weigh it first. This one must be weighed first. Okay? And then you get the combined weight of the dish one plus the 3.00 grams of your mixture. Okay, guys? Then you will go to your, when you are done with this, you go to your setup here. Your setup will be looking, let me take this out. Your setup will be looking, as you see it in the hood. Setup is made of a stand. This is a stand here. This is your Bunsen burner. This is a burner here. And then you'll get an, out of here, you'll get an O-ring. And this is shown inside O-ring here, an O-ring. Okay, to support this crucible, we'll have to have a triangle. It is, let me change the color here. You'll have a triangle clay, looks like triangle here, ceramic, to put your what? Put your weighing dish number one with your, it is, that's dish one. That's dish one, okay? You will heat this one here first. First, we have to get rid of what? Of ammonium chloride. Ammonium chloride sublimes, that's the first one we have to get rid of. We separate first ammonium chloride by heating first slowly, and then you heat a little bit vigorously, a little bit, but not too much of heat, just enough to drive all the smokes out. You will see ammonium chloride is going out as a big smoke. Are you following me here? So you get until the smoke stops, then that will tell you that ammonium chloride is driven out, is sublimed out of your mixture. There's no ammonium chloride inside your mixture, correct? You'll get this dish after it's heating. Keep it on your bench or inside the same hood. Cool it down to room temperature. Then you go and weigh. Every time you use the same balance you are using. You cannot switch balances. So use the same one you started to weigh the dish number one and the dish number two and watch glass and the mixture and everything the same balance. Don't switch balances. So then it's cooled down. But after cooling down, correct? After cooling down, then you will cool it down, and you have the mass. Okay. Now this mass is the mass of the mixture minus what? Ammonium chloride. It's gone as a smoke, correct? So if I know the sample to begin with 3 grams plus the dish number one mass minus the after sublimation, the dish and the sample left over from the sublimation, the difference between them will give me what? Ammonium chloride. Ammonium chloride. And that's, if I go down here, I hope I can go down, show you here. So here it is. If you look here, let me this is the mass of a evaporating dish by itself, correct? That's what I say. This is the mass of the sample. In your case, you have to weigh 3.00 grams. Then this 1A plus 1C. So this one here, 1A, this 1C here, 1A plus 1A plus 1B. That will give you 1C. That's 1A plus 1B will give you what? 1C. Now, after what's inside the mixture present at the beginning, you have three. You have ammonium chloride, you have sand, you have what? Sodium chloride. Those three are present. Okay. After the sublimation, the mass, take this one here, 2D, okay, 2D minus, because that's inside the initial the dish number. So 2D here, 2D minus 2D minus 1C. That will give you this amount here, 2D minus 1C. So here it is, 2D, oops, sorry. It's taking this one very quick. So this one here is, we said, 1A plus 1B. This one here, we said, mass of that you have to weight, that's the weight. So will be then mass of sublimate, ammonium chloride will be 2D from here minus the 1C. That's the initial sample started with the mass of gravitating dish, 2D minus 1C. What chemicals now inside this? After sublimation, you have only left silicon dioxide plus sodium chloride. Yes, ammonium chloride, sodium chloride, sorry. I have to. Yeah. Sorry about this. So it has to be plus sodium chloride. So we lost ammonium chloride due to sublimation. Okay, guys. Now this is the mass of the second. Let's change the color. That's the mass of the second one. After you are done with the whole thing, you have to weigh. I said, but you weigh at the beginning. Second evaporating dish with the watch glass. Here it is. This one here. You do it at the beginning. So let's put it here. Okay, guys. Then what you have to do? The same to dish number 1. You add 10 mL of what? Of tap water. Use this graduated cylinder here. Add 10 mL to after the cooled one. Dish number 1, after sublimation, after it's cooled down from heating. You weigh it already. You know the mass of it. So then you add to it 10 mL of tap water. It does not have to be still tap water. And with the police rubber, we call it stirrer, glass stirrer. You stir your solution and you decant. So to this one here, I would add 10 mL tap water to the one. It has now sand and sodium chloride. Ammonium chloride is gone. I have sodium chloride and what? Silicon dioxide, the sand. I added 10 mL with the stirring rod, stir, and then I have the second evaporating dish and decant. Try to avoid taking any particles here, any particles from sand, from the sand, because sodium chloride will be soluble in H2O. Sand will remain wet inside at the bottom. So I decant just the liquid. Then I add another additional 5 mL, second time. So, and then stir, decant to dish. This is my hand, this represents dish number 2 with the liquid here. So now I have wet, solid sand in this dish number 1. and liquid aqueous solution of sodium chloride. I evaporate this one to dryness. When it's done, I'll take it down. Then after that, dry the second one to dryness. This here, second one, we need the watch glass. What's happened is we have the effect of popcorn in the sense that when we heat, it will generate a lot of pressure on the vapor pressure of H2O will start boiling, taking the crystals out. Popcorn effect. It's sodium chloride crystals, white crystals will start popping out. So therefore, the watch glass will come to prevent this popcorn effect of the crystals of sodium chloride. So, but you have to make sure that everything is dry. The watch glass should not be wet. Everything in the crystal will be, will be dry. At the end, get a spatula, and then whatever is in watch glass, any crystal left, white sodium chloride, put it back inside dish number 2 and go and weigh, right? And you go and weigh this one here. You know this one mass, and the mass now with the sand. The difference between you weigh, the difference in weight will give you the sand amount. And here, you know that the watch glass and the dish, evaporating dish number 2, okay? It has a sodium chloride. You know it empty, how much is weighing empty? Now it's filled with sodium chloride crystals. The difference between them will give you the mass of sodium chloride. Then you make the recovery calculation. Okay, guys? I think that's all. I'm not spending that much time. The recovery is the mass of whatever you have recovered divided by 3.0 grams. That's the total. Multiply by 100. That's for each one of them. So the total what you have recovered of sand or by itself, and sodium chloride by itself, and ammonium chloride by itself, divided by the total 3 grams, multiply by 100, that will give you the recovery. Now, you'll come here down, all the way down here. Let me just take this one here. Come all the way here down. That's when you calculate the recovery. Now, you look at your recovery percentage, and you look at your percentage recovery here. It is the closer you are to 100%, the better your data is. The lower than 100%, closer you are, 80, 90, that's good. But if you get 20, 30%, means you have lost a lot of material. Okay, guys? So that's about it. And let's do the experiment. The time, it takes a long time to heat those samples. I will stop sharing and stop recording. That's all for the experiment today. Okay, guys. Do you have any question, anything? That's all for the lab today. And I'll post for you this video that's in my YouTube channel, but I'll post it in iCollege, and I just repeat myself. You use the data that is given to you in the template into the 2 parts, and just the introduction, procedure, discussion, and the conclusion. Use your own and try, even if you are working with the group classmate, you should share always this data and the results only. The other stuff, everybody in the group has its own phrasing, words and sentences, not copying from each other. Okay, guys, any other question? I will open them for the floor here for any questions you might have. Ask me. So that's the whole thing. That's the whole lab today. So any question? No. Any question?
None for me.
Okay. Well, before we leave, I wanted to have any question you have or anything. You know, it's a very simple experiment. It's not really difficult. It's a very simple experiment. It's not really difficult. Just the whole about separation of a mixture in its original 3 components. That's all. And calculate the yield and calculate the recovery. of all those three components. Okay, guys, any question? I'll put, you'll get two videos. This video here from this lecture here, WebEx, and this the one here you saw there already in YouTube. Guys, if you have no question, I'll just stop recording and then shut down WebEx. But I'm here around. If you have any question, I'm around for another maybe 30 minutes, another 30 minutes. If you have any question, please ask question. If you don't, I'm not forcing you. Like in the lab, you are done with the lab, you are free to go. So we are done with the lab. If you have no question, you can feel free to leave. But if you have any question, just let me know.
Okay, thank you.
Thank
Okay,
you,
yeah.
Dr. Taya. I'll email. I need to go
Yeah.
over it. Thank
Yeah,
you.
nothing discussion
have to.
about quizzes. Quizzes one-on-one WebEx, because some people are still doing the quizzes, so we can't do it for the whole group quiz discussion. But if you have any question, a quiz, discuss it with me in private, in email or WebEx. Okay, guys? I'll stick here to another 30 minutes. If you have questions, just let me know.
Thank you. Have a good day.
Have a nice day.
Thank you. Thank you. Okay, thank you.
Professor, I had a question.
Yeah.
So this is actually for the extra credit assignment. You said that the video would be posted somewhere, but I didn't see it.
What video?
For that one chemistry club event that was happening because we couldn't attend because it was during class hours.
Well, that's in iCollege. The first in the announcement. That was the karate,
Yeah, but
the karate one.
that video is only like 30 seconds long.
Well, at least that's what I got. I did not get more than that. Nobody had submitted anything.
Oh, okay. I was just wondering.
Only 4 students came in. 2 from Principle of Chemistry 1 and 2 from Survey of Chemistry 1. 4 students attended that, so nobody there. So the timing was not really adequate because it came. Even I couldn't even attend because I was in the lab. Oh, yeah, I was in the
Right.
lab. Yeah, so yeah, but
Alright.
you will see longer videos. You will see a lot. You can go to my YouTube channel and you see a long time ago we did a lot of activities and the students made a lot of videos, and I 99% of those videos, regardless, I just post them out for everyone. Yeah.
Okay, thank you.
You're welcome.
Excuse me.
Yes.
Can we ask you questions about like a previous lab?
Quizzes
should
and
I
stuff?
email
No. That has to be one-on-one.
Okay, a
Because
previous lab?
about the lab, yeah, you can ask me about the lab.
No,
But
it's
the
not about.
quizzes, the quizzes
no,
and
after this.
exams, I prefer you set up a time for me and you only. What's happened is in the past when I discussed this in front of the class, and then I realized that's not majority, but bunch of the students did not do the quiz, and they did better because I revealed in the discussion that student all the answers, and that's not fair for the rest of the class. So if you have any question about the quizzes, set the time in the weekend and we can WebEx like we are doing now. It will be fair for you and for the rest of the class. Yeah.
But my question was about a previous lab, not like an experiment. I mean, not
Yeah,
a quiz.
yeah.
Okay,
Yeah,
so
but
for wait, let me check it. So you sent the feedback for my I think lab, the second lab,
uh-huh.
the introduction to measurements, and you said it's what is it? It has a lot of similarities.
Yeah, it looks like
I was wondering.
from your classmates working in the group, you copied each other at almost most of the stuff. I said, although you are working together, you are allowed to share just the data and the results, but all the four components, which is introduction and procedure, discussion, conclusion, it
So
should be everyone by him or herself.
so like I think it might be the paper that I turned it in because uh the assignment that I turned in, it also
Yeah,
had all of the previous questions. You know how we had to we
yeah,
had to
that's you
measure.
are allowed to. That's you are allowed to copy those post-lab questions.
Yeah, so do I have to do them in do I have to turn in two assignments? Because I think like it's counting the even the questions as a similarity. Like I know everybody has the same questions. Maybe that's why it's counting the similarities, but
Not really. That's maybe portion. I'm lenient. I give up to 80 something, 89% of similarity, but not over 90. That's meaning most of your work is just copied from each other. Those
um
post-lab questions just maybe 15% or so. It's not that big.
15.
Yeah, 10, 15%.
Um,
Yeah, it's not that big. But the similarity will come from the fact that introduction the same, procedure the same, discussion the same, and conclusion the same. So you get about 89, 90% the same similarity. And
so
that's
what do you
yeah,
suggest I do?
you can take their introduction from the lab report example, rephrase it, and put it in your own word. The turn it in will not count it against you. And the same thing with the procedure, the same thing with with the the conclusion. I'm telling you, I'm taking 89 and above as in consideration to be similarity. But lower than that, I will let it go because the fact I'm letting you to copy and paste all the post lab questions and copy and paste all the beside this the data. So you have post lab questions and the data results are copied from each other. And the post lab is coming from the questions from the examples of the post labs. So that's that's a contribution to the similarity. But when it comes 90%, 89, 90%, it means most of your work is just within your classmate, you copied each other, so submitted the same thing. You just
So
rephrase it,
do you
just
just like rewrite it?
yeah, rephrase it. I mean, so it will look like this you are the one who is really producing it, not your classmate or not the lab report example.
Okay.
Like in some procedure, some students will write it 1, 2, 3, 4. Some students will write it in sentences, 3, 4, 5 sentences instead of 1, 2, 3, 4, 5. They'll write it in sentences, but not exact though. But rephrase it. 5 steps of procedure, maybe 2, 3 sentences. That's all. And turn it in will not account for that for you. Turn it in looks exactly has to be. Similarity means you have really copied the same with the comma, semicolon, full stop, whatever. All this, it counts. That means you are very, very similar to somebody's else work. You understand my point? But if
Yeah.
you can, the way you can I'm an author of books too. So all the authors in chemistry, we have books published with the university. We look at the whole thing, and if we can't copy each other, everyone will come and rephrase, right, the way he likes. But the content at the end, we are saying the same thing, though. Are you following me here? We are
Mhm.
writing the same thing. We are saying the same thing, but rephrase.
I think I think I figured out what happened.
Yeah, that's fine.
Um,
Don't
alright.
worry. I'm not taking any penalty. So I'm not taking any penalty for that. So
Okay.
you can just keep. Yeah.
So
So
just
I'll close.
rewrite it and turn it in.
Yes, I'm closing the recording now, I think.
Okay.